Dear colleagues, your attention is invited to a report on the topic the pseudorandom key sequences generator based on 4 sets of quaternary band sequences. The second slide shows the problem statement. The pseudorandom key sequences generator is a very important construct used in modern cryptographic applications as well as in other areas of science and technology. Pseudorandom key sequences generators is the basis for the functioning of modern stream encryption algorithms, organized in modern efficient modes for block encryption algorithms, defining the steganographic path in modern steganographic algorithms, functioning of modern radio communication systems based on frequency hopping spread spectrum technology, etc. The development of the theory of quantum cryptography, as well as the recently proposed cryptographic algorithms based on many Wordle logic functions, have led to the need to create pseudorandom key sequences generators operating on a non-binary alphabet. As the vast majority of information today is stored, processed, and transmitted in binary form, which makes it especially relevant to consider the possibility of constructing pseudorandom key sequences generators that would operate over the quaternary alphabet. The use of the quaternary alphabet fundamentally makes it possible to simplify the pseudorandom key sequences generator schemes by generating twice more gamma bits during one cycle, and also increases the possibility of implementing the principles of diffusion and confusion in the pseudorandom key sequences generators. The quaternary alphabet also provides a much greater variety of algebraic constructions that can be used to build high-quality pseudorandom key sequences generators. This fact substantiates the task of further research of the possibilities of improvement of the classical layout for constructing the pseudorandom key sequences generators operating over the quaternary alphabet. The third slide shows the literature review. The classic layout of the pseudorandom key sequences generator implies the use of linear feedback shift registers as the main component. The ideal option for nonlinear element is to use such special algebraic constructions as band functions, whose truth tables are called as band sequences, which have the maximum level of nonlinearity and, accordingly, provide the highest level of confusion implemented by pseudorandom key sequences generator. To construct a quaternary pseudorandom key sequences generator, it is proposed to use a complete class of quaternary band sequences. The fourth slide shows the theoretical material on the fourth set of quaternary band functions. Band sequences are very important mathematical objects for cryptographic constructions development. However, their main drawback, which limits their use in cryptography, in particular in the problems of development of cryptographically secure pseudorandom key sequences generators, is their imbalance, i.e., the inequality of the number of symbols contained in them. This drawback can be solved by using Q-sets of band sequences. The research of the complete class of quaternary band sequences of length 16 makes it possible to distinguish the following weight structures, which are presented in table on the slide. The fifth slide shows the theoretical material on the optimal construction of the fourth set of quaternary band sequences. Based on the data presented in table on the previous slide, as well as on the definition of the fourth set, it is fundamentally possible to construct 3,948 four sets, which can be formed on the basis of a complete class of quaternary band sequences of length 16. As the experiment shows, the best stochastic quality of the generated pseudorandom key sequences is provided with the choice of the structure, which is presented on the slide. Note that theoretically, as a linear feedback shift register, it is possible to use registers based on primitive irreducible polynomials over the external Galois field 2 in second degree. However, the results of the performed research show that linear feedback shift registers constructed using extended fields show significantly worse stochastic performance compared to linear feedback shift register constructed using prime Galois fields. This circumstance does not allow them to be applied in the developed quaternary pseudorandom key sequences generators. In our opinion, a good solution is to use binary linear feedback shift registers with their subsequent multiplexing to ensure that arguments are supplied to the input of the full set of band sequences, as well as the choice of a specific quaternary band sequence from the set is performed. The sixth slide shows the pseudorandom key sequences generator scheme for quaternary band sequences of length 16. Based on the above theoretical information, we present a quaternary pseudorandom key sequences generator scheme based on a full set of quaternary band sequences. The number of protection levels of the developed pseudorandom key sequences generator is determined both by the number of possible initial states of the linear feedback shift registers and by the number of band sequences in the complete class. In our case, the number of protection levels of the developed pseudorandom key sequences generator is defined as 2 in degree 173.6. The seventh slide shows the pseudorandom key sequences generator scheme for quaternary band sequences of length 64. We note an important property of the proposed pseudorandom key sequences generator scheme. It is easily scalable and makes it possible, if necessary, to easily increase the number of protection levels by using quaternary four sets of band sequences of greater length. For example, consider the possibility of using quaternary band sequences of length 64. For the case of our scheme for band sequences of length 64 four set, the number of protection levels is equal to 2 in degree 287. The ninth slide shows the results of the knee stochastic tests. We present the results of the knee stochastic tests of the developed pseudorandom key sequences generator, its structural elements as well as known analogs. The analysis of the data presented in table leads to the conclusion that the proposed pseudorandom key sequences generator, based on four sets of quaternary band sequences of length 16 as well as quaternary band sequences of length 64, has a high level of stochastic quality and fully complies with all the knee stochastic tests. The NIST test results presented in table, as well as the obvious simplicity of the technical implementation of the proposed pseudorandom key sequences generator structure, allows us to recommend to use both developed pseudorandom key sequences generator variants for practical use. The conclusions of the work are presented on the 9th slide. We note the main results of the research. It has been established that the construction of quaternary pseudorandom key sequences generator is possible on the basis of binary linear feedback shift registers as well as four sets of quaternary band sequences. At the same time, the configuration of the four set was found, which provides the best stochastic properties of the gamma generated by the pseudorandom key sequences generator. The scheme of the pseudorandom key sequences generator is proposed, which is based on binary linear feedback shift registers and four set of quaternary band sequences. The proposed pseudorandom key sequences generator provides a high level of stochastic properties of the generated sequences and the number of protection levels that can be easily scaled. For the case of use of the full class of quaternary band sequences of length 16, the number of protection levels reaches the value 2 in degree 173.6, while in the case of using band sequences of length 64, the number of protection levels reaches the value 2 in degree 287, which exceeds the number of protection levels of the IS-256 cryptographic algorithm. Develop pseudorandom key sequences generator also requires 40% smaller number of linear feedback shift registers for generation of quaternary pseudorandom key sequences, compared to combining of two pseudorandom key sequences generators based on dual sets of band sequences. The presented pseudorandom key sequences generator is of interest from the point of view of practical application where quaternary pseudorandom key sequences are needed. For example, stream encryption algorithms operating based on many logic principles, communication systems based on the frequency hopping spread spectrum technology, steganographic algorithms with the possibility of pseudorandom selection of a steganographic path. The 10th slide shows the contact information.